Welcome back to Stoichiometry Part 2. So here we got the same situation. We've got to write a balanced equation. We got to write the words, the balanced equation, types of reaction, and then we're going to start the stoichiometry. So pause the video, see if you could work it out, and then start the video again and see how well you do. We're going to pick it up with letter E. All right, double replacement again. Check your answers. Not a redox, and it is a 3, 2, 1, 3. If you put it in this order, how it went, make calcium phosphate and sodium oxide. How'd you do? All right, so we're going to write our given, and you don't have to do this. Again, this just helps you know where to start and where to end. And so I see that word excess, so I'm going to get rid of that. And I'm looking for moles of calcium oxide this time. So I'm starting with 17 grams of calcium phosphate. 3 and a 2, we swapped those, and I'm looking for moles of calcium oxide. All right, so this time I'm starting with 17.0 grams calcium phosphate. And we're going to bring down grams of calcium phosphate. Now, I can't switch. I can't switch to a different label, and the reason I can't switch to CaO yet is because this doesn't say mole. This bottom right corner here needs to say mole, and you don't just write the word mole, it needs to write. So I need this to still be calcium phosphate, but I need to switch it to the mole. So when in doubt, go to the mole. When in doubt, go to the mole. Okay, so this is going to cancel with this. Anytime mole and gram are together, anytime mole and gram, mole will always get a 1. Mole and gram, mole gets a 1. This will be the molar mass off of the periodic table. 3 calciums, 2 phosphoruses, and 8 oxygen. This is going to equal 310.18. Now, if you're having trouble with molar mass, where that's coming from, please come see me. All right, I'm not looking for a mole of calcium phosphate, so I got to keep going. So now I'm going to bring mole down. Now, the minute mole gets in this right corner, I can switch it to mole of something different. Whatever they want me to find, anything in that balanced equation. It's called the mole-mole ratio. Everything should have a mole-mole ratio in it. If you don't have a mole-mole ratio, you're not doing stoichiometry. Thus far, we have not done stoichiometry. So you can see this is canceling. Where are these numbers coming from? They're the mole-mole ratio, so they're coming from our balanced equation. So in front of calcium oxide, there is a 3, and in front of calcium phosphate, there is a 1. So there's a 1 with that. So I'm going to stop because, see, I've got what I want. The reason I like students to do this is because that way you know where to stop. Sometimes students will take them all very far. Once y'all do the next type, students like to do those mostly. So we're going to multiply across the top, divide by our bottom, and we should be getting a 0.164 moles of calcium oxide. All right, one more example. Same thing now. Stop your video and see if you can write out and figure out what type of reaction this is. Okay, how'd you do? Combustion reaction is a redox. I know in your paper you might have what's oxidized and reduced. Remember, I'm not going to ask that for combustion. Just forgot to erase that off of there. So on combustion, I won't ask that question. So oxygen, carbon dioxide, and water, it is harder to balance. Remember, you get something odd and you have to double everything. All right, so if you have trouble with that, come see me. So we've got our given and our wanted. So I've been given that many grams. We're going to go ahead and mark through that excess, and we're looking for grams of water. So 16.5 grams of butane. But is 4 times 2 plus 2. And you're looking for grams of water. So we're going to begin with the 16.5 grams of butane. Bring grams of butane down. Okay, we can't switch to water yet, so this still has to be butane. You can't switch unless this says mole. So if you're starting with grams, you got to go to mole first. Anytime gram and moles together, mole gets a 1, okay? What goes with grams? Molar mass, so that's 58.14. All right, so now I have moles of butane. I'm going to bring moles of butane down. Now I can switch to moles of water, just like before. These numbers are coming from the balanced equation. Now, with me saying this, we're not done with this, but some of you will mess up on the balanced equation. Can you see that there's 1, 2, 3, 4, 5 parts to this problem? If you can't balance an equation, make up some coefficients and go ahead and do your stoichiometry. As long as you're using your coefficients that you have up here in this, I'll give you full credit for this down here because I'm grading your work. Okay, you'll miss the points on balancing, but I'm not going to double mark them wrong. So please don't just leave them blank if you can't get an equation to balance. And if I were making up coefficients and I knew that, I don't know how to balance it, my coefficients would all be 1. That makes this ratio 1 to 1. You do still have to put the ratio. All right, so this is, can you see what's canceling here? I'm not done because this time I'm wanting grams, so I've got to go a little bit further. I've switched to the right unit now. Got moles of water. From moles of water, I can go to grams of water. Anytime mole and gram are together, mole will always get a 1. And this will be the molar mass. And maybe from those hydrates, you might remember the molar mass of water being 18.02. If not, 1 oxygen, 2 hydrogens. Now I'm going to multiply across the top, get an answer, multiply across the bottom, get an answer, and then take the top divided by bottom. So you need to be careful when there's 2 numbers down here. So you might want to check, make sure in the calculator you're putting it in correct. This is 25.6 is the answer you should be getting for this problem. Check to see if you can put it in correctly. All right, that is the last type of the stoichiometry. See you next time for limited reagents.